All started with a dream, a vision of reaching beyond the sky, beyond the stars, into the unknown. Centuries ago, one man dared to imagine rockets soaring through the cosmos when the world still believed flight itself was impossible. Decades later, that dream turned into fire and steel, propelling humanity beyond Earth's grasp. From the first bold thinker to the pioneers who walked on the moon, every breakthrough brought us closer to answering the ultimate question: how far we can go. And now in 2025, we stand on the edge of another space revolution. Missions to Mars, asteroid mining, space telescopes that could reveal Earth-like planets, and the race to colonize the moon. What happens next might change the course of history forever. This is the story of space exploration, from the very first person who dared to dream to the incredible future unfolding before our eyes. We'll reveal the struggles, the triumphs, and the moments that defined our journey to the stars. But as we look back at how we got here, one question looms larger than ever. Are we ready for what's coming next? By the end of this video, you won't just see space as a distant frontier. You'll feel the weight of history, the thrill of discovery, and the endless possibilities of what lies ahead. Buckle up, because this is the greatest adventure ever told. For thousands of years, humans gazed at stars and wondered, what is our place in the universe? Around 300 BC, the Greek philosopher Aristotle of Samos became the first recorded person to propose that Earth orbits the Sun, an idea that completely rejected at the time. The prevailing belief, led by Aristotle and Ptolemy, was that Earth was the center of everything. The Babylonians, 1600 BC, and Mayans, 250 AD, developed some of the earliest star charts, tracking celestial movements with incredible precision, but they saw space as realm of gods rather than a place humans could reach. For centuries, the idea of traveling beyond Earth remained unimaginable until a few bold minds began to challenge everything. For over 1,000 years, humanity believed that Earth was the center of the universe. But in 1543, a Polish mathematician named Nicholas published a book that shattered this belief. In that book on the revolutions of the celestial spheres, Nicholas proposed the heliocentric model, the idea that the Sun, not Earth, was the center of the solar system. It was a radical idea, one that many refused to accept. Yet without this discovery, the very concept of space exploration would have been impossible. If Earth was just another planet orbiting the Sun, what stopped us from reaching the others? But proving this theory would take more than just ideas. It would take observations, mathematics, and a new way of looking at the cosmos. In 1609, a curious Italian scientist named Galileo Galilei built his own telescope and pointed it at the night sky. What he saw changed everything. He discovered mountains on the moon, proving that it wasn't a smooth, perfect sphere as many believed. He observed Jupiter's 4 largest moons, proving that not everything revolved around Earth. He studied the phases of Venus, which confirmed Nicholas' heliocentric model. Galileo's discoveries shattered the old worldviews and proved that space was more than just distant lights. It was a real physical place. But even with these breakthroughs, the idea of reaching space was still centuries away. While Galileo was observing the sky, a German mathematician named Johannes Kepler was uncovering the rules that governed planetary motion. In 1609, he published Astronomia, a novel which contained Kepler's first and second laws of planetary motion. Planets move in elliptical orbits around the Sun. Planets move faster when they are closer to the Sun. Then in 1609, he published his third law, which revealed a precise mathematical relationship between a planet's distance from the Sun and its orbital period. But Kepler wasn't just a scientist, he was also a dreamer. In 1608, he wrote a short story called Somnium, which means the dream, which imagined a journey to the moon. He described how Earth's gravity would weaken as one ascended. Centuries before space travel became reality, Kepler's laws would later become essential for rocket scientists, because to reach space, you first need to understand how objects move in it. If Kepler built the foundation, Isaac Newton built the blueprint. In 1687, Newton published the three laws of motion, explaining how objects move. The universal law of gravitation, which described how gravity governs planets, moons, and even artificial satellites. Newton even imagined how spaceflight could work. He described a thought experiment known as Newton's cannonball. If a cannon were placed on a tall mountain and fired fast enough, the projectile would orbit Earth rather than fall back. This was the first real explanation of how an object could be sent into an orbit, a concept that wouldn't be realized for another 270 years. For thousands of years, space was a mystery. For centuries, it was thought to be unreachable. But the discoveries of Nicholas, Galileo, Kepler, and Newton transformed spaceflight from an impossible fantasy into a scientific possibility. The dreamers of the past never saw their ideas come to life. They never saw a rocket launch, a space station, or a man walk to the moon, but their ideas survived. And as we stand on the brink of new space discoveries in 2025, we owe everything to those who dared to ask, what if we go beyond? As we continue our journey through the history of space exploration, we find ourselves entering the 20th century, where the seeds planted by early visionaries like Nicholas, Galileo, Kepler, Newton, and Tesla begin to bear fruit. The dream of reaching the stars moved from the realm of theoretical possibility to actual scientific exploration. It was during this time that the foundation of modern rocketry, space science, and exploration took shape, fueled by the unrelenting curiosity and brilliance of countless individuals. We had already witnessed the beginning of rocketry and theoretical concepts for space travel in the late 1800s and early 1900s, but now the 20th century would bring these ideas into the realm of reality, an era marked by scientific discovery, technological breakthroughs, and the rise of space pioneers who would forever change humanity's relationship with the cosmos. As the 20th century dawned, the world had begun to understand the possibilities of space exploration. Robert H. Goddard, an American physicist, was the first to successfully launch a liquid-fueled rocket, a technology that would become central to future space missions. On March 16, 1926, Goddard's rocket, known as Nell, took flight in Hebron, reaching a height of just 41 feet but achieving a significant milestone in space exploration. His work also included the development of gyroscopic control system and other key technologies, laid the groundwork for future rockets that could travel beyond Earth's atmosphere. Though his achievements were met with skepticism in his lifetime, Goddard's contribution formed the bedrock for modern rocketry. His pioneering designs for liquid fuel propulsion and other innovations would inspire the generations of engineers and scientists who followed. Meanwhile, in Europe, Hermann Oberth was exploring similar concepts. His influential book, The Rocket into the Planetary Space, 1923, presented detailed calculations and conceptualized the notion of human exploration beyond Earth. Oberth's work was groundbreaking, leading him to inspire a new generation of rocket engineers. By the 1940s, rocketry had made significant strides, and it was the German engineer Werner von Braun who would become one of the most influential figures in this field. During the World War II, von Braun developed the V-2 rocket, the world's first long-range guided missile, which would later form the basis of modern space launch vehicles. After the war, he was brought to the United States as a part of Operation Paperclip, where his talents were redirected to peaceful civilian space programs. In 1955, von Braun began working with NASA to develop rockets for space exploration. His leadership in the development of Redstone rocket, which would carry Alan Shepard into space in 1961, helped the United States into the space race. But it was his work on the Saturn V rocket, the vehicle that would eventually take Apollo 11 to the moon, that marked one of the greatest achievements. Von Braun's work provided the technological foundation for human space flight. In the Soviet Union, Sergei Korolev was quietly building the rockets that would lead the Soviet Union's dominance in the early space exploration. Korolev was considered the father of Soviet spaceflight, was instrumental in the development of R-7 rocket, which became the first intercontinental ballistic missile. The R-7 would also serve as the launch vehicle for Sputnik 1, the world's first artificial satellite, which launched in October 4, 1957. This achievement was a stunning moment in history, sparking the space race between the United States and the Soviet Union. Korolov's work, after done in secret due to political and military secrecy, ultimately paved the way for the first human spaceflight when Yuri Gagarin became the first human to orbit Earth on April 12, 1961, aboard Vostok 1. Gagarin's flight was a triumph of Soviet engineering and a symbol of human potential. The race to the moon culminated with Apollo 11 in 1969. When Neil Armstrong and Buzz Aldrin became the first humans to set foot on the lunar surface. The Apollo program, a decade-long effort by NASA, was an ambitious undertaking that required a huge leap in technology, science, and engineering. It was driven by scientific knowledge of the previous pioneers and the tireless efforts of thousands of scientists and engineers working in the background. Key figures like John C. Hubble, whose lunar orbit concept for the Apollo mission became essential to the success of the mission, and Katherine Johnson, the African-American mathematician whose calculations helped ensure the Apollo 11 mission's success, were central to the mission's historic outcome. Armstrong's words, "That's one step for a man, a giant leap for mankind," echoed the culmination for centuries of scientific pursuit. From Tsiolkovsky's rocket equation to Goddard's liquid fuel propulsion system, the Apollo's missions also provided invaluable scientific data about the moon's surface, geology, and potential for future exploration. The development of the lunar rover, a vehicle that allowed astronauts to explore a wider area on the moon's surface, and the collection of rock samples further enriched our understanding of the moon's composition and its history. These discoveries continue to inform future lunar exploration efforts. By the 1980s, space exploration entered a new era with the Space Shuttle program. The shuttle's reusability allowed for more frequent missions to low Earth orbit and created new opportunities for scientific experimentation. Columbia, the first space shuttle, was launched in 1981, making the beginning of an era where astronauts could regularly live and work in space for extended periods of time. The Space Shuttle program provided the opportunity to deploy crucial scientific instruments, including the Hubble Space Telescope. Launched in 1990, the Hubble Space Telescope became one of the most important instruments for space exploration, allowing scientists to peer into the farthest reaches of the universe with unprecedented clarity. It provided stunning images of distant galaxies, nebula, and stars, and its findings reshaped our understanding of the universe. Among its groundbreaking discoveries was evidence of dark energy, the mysterious force causing the acceleration of the universe's expansion. By the turn of millennium, the efforts of pioneers like Robert Goddard, Wernher von Braun, Sergei Korolev, and countless others had transformed the once impossible dream of space travel into an achievable reality. Their contributions, rooted in scientific discovery and an unyielding pursuit of knowledge, had laid the foundation for modern space age. As we move forward into the 21st century, the journey to explore the cosmos is far from over. With the potential of human missions to Mars, robotic probes exploring the outer planets, and the continuous discoveries from space telescopes, humanity's story in space is only just the beginning. Building upon the legacy of Goddard's early rockets, von Braun's engineering feats, and Korolev's visionary accomplishments, the dawn of the 21st century heralded a transformative period in space exploration. This new era is marked by groundbreaking scientific missions, advanced technology, and an unprecedented collaboration between government agencies and private enterprises. With every launch, probe, and rover, humanity has inched closer to answering some of the universe's most profound questions. The exploration of Mars has been one of the most thrilling chapters of new space age, driven by a series of robotic missions designed to uncover the planet's past and assesses its potential for life. Launched in 2003, NASA's twin rovers, Spirit and Opportunity, were tasked with exploring the Martian surface in search of signs of ancient water. Both missions far exceeded their original 90-day plans. Opportunity, for instance, provided evidence of past water activity, finding minerals and rock formation that hinted at Mars' better past until communication was lost in 2018. These rovers not only transformed our understanding of Martian geology but also set the stage for more sophisticated exploration. The Mars Science Laboratory mission, with its Curiosity rover landing in 2012, brought advanced analytical tools to Mars, equipped with instruments capable of drilling into rock and analyzing its composition. Curiosity discovered complex organic molecules and variations in atmospheric methane. Its findings have deepened our understanding of Mars' ancient environments, suggesting that the red planet may have once harbored conditions favorable for microbial life. Continuing the quest, the Perseverance rover touched down in February 2021 in Jezero Crater, a site believed to be an ancient lake bed. Its mission is twofold: to search for biosignatures of past life and to collect rock and soil samples for future return missions. Accompanying Perseverance, the Ingenuity helicopter was demonstrated the first powered flights in the Martian atmosphere, opening a new chapter in aerial exploration of another planet. While Mars captured our immediate attention, the quest to understand other planetary systems has exploded, with new discoveries thanks in large part to space-based observatories. Kepler's space telescope was launched in 2009. Kepler revolutionized the search for planets beyond our solar system by monitoring the brightness of over 150,000 stars. Through the transit method, it detected thousands of exoplanets, many of which are Earth-sized and located in their star's habitable zone. These findings have dramatically shifted our perspective on the galaxy, revealing that planetary systems are common and diverse. Building on Kepler's legacy, the Transiting Exoplanets Survey satellite TESS, launched in 2018, has continued the search, focusing on nearby bright stars. This has not only expanded the exoplanet catalog, but also enabled detailed follow-up studies with ground-based observatories and future space telescopes, further unraveling the conditions that may lead to habitable environments. Perhaps the most ambitious astronomical project of the new space age, the James Webb Space Telescope, represents a quantum leap in our ability to study the universe. Launched in December 2021 and positioned at the Earth-Sun L2 point, James Webb Space Telescope is equipped with advanced infrared instruments designed to peer into the earliest epochs of the universe. Its ability to observe in infrared light allows it to study the formation of the first galaxies, probe the atmospheres of exoplanets, and reveal details hidden behind the cosmic dust clouds. Since releasing its first image in 2022, James Webb Space Telescope has provided astonishing views of distant galaxies, star-forming regions, and planetary systems. Its data is already reshaping theories about the cosmic evolution and are expected to drive major scientific discoveries for decades. The success of this telescope is a testament to the ingenuity of the thousands of scientists and engineers, including key figures like Nobel laureate John C. Mather and many other contributors whose collaborative efforts made this instrument a reality. The defining feature of 21st century has been the rise of private space companies that have radically altered how we access and explore space. SpaceX was founded in 2002 by Elon Musk. SpaceX set its sights on making space travel more accessible. Its early milestone came with a successful orbital flight of Falcon 1 in 2008. Subsequently, the development of Falcon 9 rocket introduced reusable technology that has since become a cornerstone of modern spaceflight. The Dragon spacecraft's historic 2012 mission to the International Space Station and the successful crewed flights aboard Crew Dragon in 2020 underscored SpaceX's pivotal role in human spaceflight. The ambitious Starship program aims to enable deep space missions, including future endeavors to Mars. Jeff Bezos' Blue Origin has similarly pushed the envelope with its focus on reusability and innovative engineering. The New Shepard suborbital vehicle, which has conducted multiple successful flights since 2015, has paved the way for future orbital and beyond missions with the forthcoming New Glenn rocket. NASA's Artemis program announced in 2017, Artemis is designed to return humans to the lunar surface and establish sustainable exploration by the late 2020s. Artemis 1, an uncrewed test flight of the Orion spacecraft, successfully launched in 2022, setting the stage for the future crewed missions. Artemis 3 is slated to land astronauts, marking the first time in over 5 decades that will include the first woman and the first person of color on the moon. These missions are not just a return to our lunar neighbor, but also a stepping stone toward eventual human missions to Mars. Parallel to these efforts, China has demonstrated remarkable progress with its Chang'e program. Chang'e 4 achieved the first soft landing on the far side of the moon in 2019, and Chang'e 5 returned lunar samples to Earth in December 2020, providing fresh insights into the moon's composition. In addition, China's Tiangong space station, assembled in 2020, serves as a modern laboratory for long-duration space research and technology demonstrations. Beyond planetary exploration, new missions have expanded our understanding of the Sun and the outer reaches of the solar system. Parker Solar Probe was launched in 2018. NASA's Parker Solar Probe has set records by approaching the Sun closer than any previous spacecraft. Its observations of the solar corona, solar wind, and magnetic fields are providing crucial data to better understand the mechanics of our star, which in turn affects space weather and planetary environments. Now let's talk about the Voyager's enduring legacy. Although launched in 1977, the Voyager 1 and 2 spacecraft continue to rely on valuable data from interstellar space, extending humanity's reach far beyond the solar system. Their enduring journey underscores the timeless quest for knowledge that characterizes every era of space exploration. As we progress through the 2020s, the foundation laid by these missions point to an exciting future of exploration. Ambitious plans for sustained lunar bases, human missions to Mars, and the next generation interstellar probes are on the horizon. With the combined expertise of government agencies and private enterprises, each mission builds on the last, pushing the boundaries of our technological and scientific capabilities. As the foundations laid by decades of pioneering work, from Goddard's first liquid-fueled rockets to the transformative missions of a new space age, continue to inspire. 2025 is poised to be a landmark year in the space exploration, building on the successes of robotic explorers, advanced space telescopes, and revolutionary private enterprise. The upcoming missions and technological advancements promise to deepen our understandings of the cosmos and prepare the way for sustained human presence beyond Earth. One of the most anticipated events of 2025 is the continuation of NASA's Artemis program. Following the successful uncrewed Artemis 1 and subsequent orbital missions, Artemis 3 is expected to mark the long-awaited return of astronauts to the lunar surface. This mission isn't simply a revisit, it's an opportunity to deploy next-generation scientific instruments, advanced geophysical tools, and mobile surface laboratories will be used to conduct detailed surveys of lunar geology, analyze soil composition, and search for volatile compounds. These measurements will provide crucial data about the moon's history and its potential resources. This mission will include experiments in habitat construction, power generation, and resource utilization, such as extracting oxygen and water from lunar regolith. These technologies are essential stepping stones for lunar bases and eventually human missions to Mars. Inspire a new generation explorer. The crew selected for their expertise in geology, robotics, and space system will not only conduct research but also serve as ambassador of human ingenuity, demonstrating that decades of incremental progress have prepared us for the next giant leap. In parallel with lunar ambitions, the quest to understand our neighboring planets continue to focus on Mars. The Perseverance rover has already laid the groundwork by collecting diverse samples, and plans for a Mars sample return mission are expected to advance significantly in 2025. The goal is to retrieve precious samples from Mars and bring them back to Earth for high-precision laboratory analysis. These samples hold the key to understanding Martian climate history, geological process, and the potential for ancient life. The mission will involve a series of coordinated robotic landings and autonomous operations showcasing the next generation of interplanetary robotics. Building on the technological successes at Mars, future missions targeting asteroids and the moons of the outer planets are under study. These missions will further elucidate the building blocks of our solar system and provide insights into the origin of organic molecules and the preconditions for life. The legacy of the Hubble and James Webb Space Telescopes is set to continue with a new wave of astronomical observatories designed to answer fundamental questions about the universe. The Nancy Grace Roman Space Telescope, scheduled for launch in 2025, this wide field observatory will complement James Webb Space Telescope by surveying vast areas of the cosmos in unprecedented detail. Its mission will include mapping dark energy and dark matter. By capturing large-scale cosmic structures, the telescope will help refine our models of the universe's expansion and the mysterious forces that drive it. And expanding the exoplanet census with a wide field of view, it will detect and characterize exoplanets orbiting distant stars, providing a broader context for the diversity of planetary systems. Private companies have become indispensable partners in modern space exploration, and 2025 is set to be a year of significant milestones driven by commercial innovation. Following a series of successful tests, SpaceX is expected to conduct crucial Starship flights that demonstrate its readiness for deep space missions. Its objectives would be long-duration test flights, validating life supports and propulsion systems necessary for future missions to Mars and beyond. Lunar and Mars payload delivery, demonstrating the capability to carry large payloads for both scientific instruments and potential crewed missions. Blue Origin, with its new Glenn rocket progressing through rigorous testing, Blue Origin is positioning itself to offer robust and flexible launch capabilities. This progress is crucial for supporting a diverse array of missions, from satellite constellations that enhance Earth observations to exploratory missions to the Moon and deep space. As we look to 2025, the horizon of space exploration gleams with promise. From the return of humans to the Moon under the Artemis program to the groundbreaking advances in robotic exploration, space telescopes, and commercial spacecraft, every mission is a testament to our relentless curiosity and determination. With each new discovery, we not only unlock secrets of the cosmos but also pave the way for humanity's future among the stars. As we close this chapter on this incredible journey of space exploration, from the early groundbreaking rockets of the past to the visionary missions poised for 2025, we are reminded that the story of our quest to understand the cosmos is ever evolving. Every milestone, every technological breakthrough, and every daring mission is a testament to the relentless spirit of human curiosity and ingenuity. In 2025, the legacy of decades of research, innovation, and exploration will continue to unfold. Whether it's the return to the Moon under the Artemis program, the bold steps toward the Mars sample return, or the launch of next-generation observatories that promises to reveal the hidden secrets of the universe, the future is as bright as the stars we seek to understand. Thank you for joining us on this journey through the rich history and the promising future of space exploration. As we look up at the night sky, we are not just witnessing distant lights, but the culmination of centuries of scientific discovery and the spark of dreams that propel us forward. Until our next adventure, keep exploring, keep questioning, and keep looking to the heavens, because the best is yet to come.